Okay. Today we're going to be talking in the world of congruent triangles, how congruent parts make congruent triangles. We're going to start to see how kind of two triangles relate together. This is a brief introduction to one right here. I have two triangles here. I have triangle ABC and triangle ZYX. Alright, so what we have to do is we have to identify, first we're going to figure out how to identify which parts are congruent to which parts. Now, Ethan Raditz, what does congruent mean? They're the same, right? So, now look at these lines. I know I've pointed out a few of these lines to you guys before. These lines mean something. And these angle lines mean something. For example, angle A. How many lines does angle A have? 2. So to be able to see which angle it's congruent to over here, we have to find the angle that has 2 lines. So we know that angle A is congruent to angle Z. That's one part that's congruent. Angle A is congruent to angle Z. Look, A to Z, right? Because this has 2 lines. This has 2 lines. Luckily, no, I'm just kidding. Okay, angle B is congruent to angle Y, because angle B has 1 line, angle Y has 1 line. And angle C is congruent to angle X, because angle C has 3 lines, angle X has 3 lines. Okay? And that's how you register if angles are congruent, is by those little curved lines inside of the angle. So 1 line is congruent to 1 line, and so on and so forth. The same thing happens over here. So, Sam, which line segment over here on this triangle is congruent to AB? Hold on, look at it. AB has how many? Yeah, so AB has 3 lines. Which one did you say? Perfect. Now, could you write YZ?
No.
I wouldn't like it to, because AB is written from the 2 line to the 1 line, but it's the exact same measurement, so I think it'll allow you to write it either way, right? It's not going to matter. I like the fact that he went that way, but anyways, I think it'll take it either way. But I like it where he went from, where it says A to B, A's from 2 line to 1 line. He went from 2 line to 1 line. So AC goes from 2 to 3, so this would be ZX on that one, right? Okay, BC goes from 1 to 3, so this one would be YX. Okay, now that we know that all parts are congruent, so there's 6 parts to a triangle. There's 3 sides and there's 3 angles. If those 6 parts of one triangle are congruent to 6 parts of another triangle, then we know those 2 triangles are congruent. And there's a congruence statement that you're going to write. Hold on just a sec. You're going to write it like this. BAC is congruent to triangle YZX.
Doesn't matter which letter is first.
Yeah, these ones need to match up. So B has 1, A has 2. Now it doesn't matter if you have the 1, 2, or 3 mixed up. But if you have the 1 here, you have to have the 1 here. If you have the 2 here, you have to have the 2 here. If you have the 3 here, you have to have the 3 here. If you had the 3 first, but I don't think it matters overall. But
So it could be an ABC, but
we're trying to prep you for when you get to trigonometry. Like right now, really, no. But trigonometry, it's going to matter. That you get used to writing things exactly. This is another reason why I'm not a huge fan of geometry, is this kind of stuff right here. Because geometry is absolute perfection. You have to be perfect in how you write things. Now this right here means triangle BAC. Has anyone ever seen something written like that? Okay, Tyson, question?
wait, well, the question I was going to ask you, is there such thing as a shape that has like a different amount of angles and sides?
No, because like quadrilaterals have 4 sides, 4 angles. So no. Unless you have 2 completely different sides.
No.
Circles 1 and 1.
2 and 2.
Not really. Okay, here we go. All right, any questions on how to write triangles congruent and how to prove that two triangles are congruent? Okay, we got to go on to the next part. This lesson's kind of broken into two oddly different parts. The next part, and so this is like, so there's that, boom, line, transformations. Just call it transformations. Okay, there's three different types of transformations. And this is how shapes are kind of moved. So shapes can be moved different things. Does anyone know what a transformation is inside of math, or a name of one of them? Yeah? Tyson?
Reflection.
Reflection's one of them. Okay, so let's start with that one.
Translation.
Reflection is one of them. So can someone give me their definition of reflection, what they think it would be?
Mirrored image.
Okay, good.
Oh, yeah.
He's on fire.
Mirrored image. So an example of a reflection would be if I have a triangle like this. Another one, a reflection one would be that. Or if you have like a weird thing like, I don't know, if you had something like this, which you could, it would be this.
Wait, what kind of shape?
They're going to give you weird ones today. Just get ready.
Is it a 1, 2, 3?
Okay, so that's an example of a reflection.
Wait,
Okay, that's an example of reflection. So that's one way. What's another? Translation.
what?
Translation. Can anyone give me a definition of a translation?
Moving it
When I
without
move.
changing the size.
Okay, moving it without changing it. So for example, an example of translation would be like if I have, I'm going to draw you a weird one here. If I have that and it just goes to like over here. That's Utah. Looks just like it.
Utah has some bad.
No, but she-
I didn't know you were such an artist.
Look,
Idaho.
here's Kanab.
Where's the land on the right?
This is San Juan.
That's no one.
Okay, so that's an example of translation. So that's the second one, moving something. What's the other example? Rotation.
But what about the one we make it bigger and smaller?
That's not, and we'll talk about that one later.
But it's part of it.
Yep.
Let's go.
Rotation. What is rotation? What's the definition?
Rotate.
How about just, how would we write this without keeping it word? Spinning it on an axis. Can we say that? Yeah, but you can't use rotate in rotation.
That's not how the word can't be the definition.
If I was to define small and I said something small, it doesn't work.
Yeah, because what does small mean?
No, it wouldn't, because you don't know what small means.
Yeah, well, Google does that.
Okay, here we go. You guys want a weird picture of a thing here? Here, let's call, here. Yeah, that wouldn't work.
Beautiful. The bubble light is
Definitely. We should do some show the other night. It was a good show.
Wow, they are not even close to the same. It's the same shape. They're getting spun.
What'd you try to draw?
I drew that. Just random stuff. I actually saw this one on your Alex last year, and I know you're going to have one again, just like that. It's weird looking, I know. So, anyways, that's it. Okay, well, that's it. So those are the three different types of translations.
Wait, give me a second.
Copy it. Transformation. Sorry, transformation. Yes, sorry.
Kind of a hard line.
All right.
Name
Let me just see here. I think this is going to start asking us for side, 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 and stuff like that. So just
it. Oh my gosh, I cannot draw that shape.
all right.
Can I draw a circle?
Lastly, Let me see if this is what we want right here. Alright, lastly, and I'm not going to put, I played the video for you guys last year, you don't need to watch it again.
Yeah, wait,
I'll show Tyson when I get done teaching, but we don't want to waste time on the video, okay? We'll show it at the very end. So there's, now that we talked about that, we're going to kind of go back to triangles. There's 4 different ways to prove that 2 triangles are congruent, okay? There's 4 different ways to prove that 2 triangles are congruent. The first one, we're going to start off with side, 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 which is abbreviated. I don't know why I wrote it like this. I should have wrote it side, 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 and then abbreviation. I don't know why I did this. So side, side, side. What that means is, if I have a triangle like this, and another triangle, and I'm told that this angle is congruent to this angle, I mean that side's congruent to that side's congruent to that side, and this side is congruent to this side, then I know that those 2 triangles are congruent. Yes, by side, side, side. Okay? So, if 3 sides of one triangle are congruent to 3 sides of another triangle, then those 2 triangles are congruent, which means all parts of those triangles are congruent. So at the beginning of this lesson, we learned how many parts are there to a triangle? 6. If the 3 sides of one triangle are congruent to the 3 sides of another triangle, then all 6 parts of this triangle are congruent to all 6 parts of this triangle. Does that make sense? So which means that this angle right here is congruent to this one. It doesn't tell us, but we know it is. This one up here would be congruent to this one. This one down here would be congruent, and so on and so forth. Okay? Any questions on that? So the first one, side, side, side. I didn't mean to write this extra little line here. So, okay, next one is side, angle, side.
that's not how they abbreviated it.
They abbreviate it SAS.
No,
You can't do ASS
I'm just kidding.
because it's not read ASS.
And it would be funny.
Yeah, that'd be funny.
No, it's because you read it side to angle to side.
No, that's not how I do
See,
it.
it's fast instead of dumb.
That doesn't,
Instead of dumb.
that doesn't help my way of learning.
So the first way is side, side, side. If all 3 sides of one triangle are congruent to 3 sides of another triangle, then all parts of those 2 triangles are congruent. This one, if a side and the angle included, which means the angle between the 2 sides, it has to be the angle between the 2 sides. It cannot be this angle out here. It has to be a side, an angle next to it, and the other side. So it has to have the angle between the 2 sides. If that's the case, then every part of those 2 triangles are congruent. Okay, next one. Angle, side, angle, which is angle,
Why did you say angle the last name?
side.
Angle.
I don't know. Okay, yeah,
So on the first one, you did SSS parentheses side by side.
I know I botched it, right?
I know, I kept doing it.
What the heck, dude?
Just switching it up, man, you know? Making you feel happy. Okay. Now this one says this. If 2 angles and the side between them are congruent to 2 angles and the side between them of another triangle, then all parts of those triangles are congruent. So if two angles and a side included are congruent to 2 angles and a side included, then all parts of those triangles are congruent. Meaning this angle would be congruent to this angle. This side would be congruent to this side. This side would be congruent to that side. Okay. The last one. Angle, angle, side.
Wait, does angle not work?
Nope. I'll show you why.
Because doing the sides is a lot more.
Yep.
Hey, no swearing.
It was
Yeah, you're right.
Okay, so the last way is angle, angle, side. And those are the ways you prove that two triangles, prove,
You're struggling.
right?
This is why you keep his back.
Amen. That and I'm not a serial killer, huh? Just kidding. Just kidding. You guys know I'm not a huge. I don't know how to do English very well, so this is us. All right. Hence, I can barely write side with it, make it legible. So those are the 4 ways to prove that two triangles are congruent: side, 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 angle, side, angle, side, angle, 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 side.
Angle. You can say it's so weird. Angle.
Okay. So, any questions on any of that? Tyson, questions?
Can I work studio?
Yeah, you will.
Wait, are you gonna give us time to pass you our math report? We have to do that in what the heck, dude?
Okay.
Hey,
Your assignment's up there.
you do it.